Algebra 2, Lesson 29, Uniform Motion Problems of Distance plus Distance equals k. So this is different from the previous uniform motion problems that we'd been doing, where the distances were equal to each other. Now we're adding up two distances to equal an overall distance. So with our practice, we see that at 1 p.m., Chester left the roundup and began the 66-mile trip to Dodge City. At 2 p.m., Marshall Dillon left Dodge City to meet Chester. Marshall Dillon's speed was twice that of Chester, and they met at 9 p.m. How fast did each man ride? So, we're going to pull the important information here, which is that Chester left and began the round trip, or began the 66-mile trip to Dodge City. So the total distance is going to be 66 miles. That's where he's trying to go. And then at 2 p.m., Marshall Dillon left and met Chester. So, when we draw this in a diagram, what we're seeing here is from the starting point to Dodge City is 66 miles. They tell us that this whole trip is 66 miles. And they tell us that Chester leaves and goes this way, and Dillon leaves and meets him somewhere in the middle. So here we have the distance of Chester, or D sub C, and here we have the distance of, we'll call him Marshall, distance of M, D sub M. So when we draw this diagram, it's easy for us to see that DC plus DM equals 66. So that's going to be our first equation. D sub C plus D sub M equals 66. Now we're going to start rewriting our equation, substituting, and all that good stuff. So we should have already memorized the equation distance equals rate times time. And we're going to use this equation that we know to substitute for D sub C and D sub M. So instead of writing D sub C, I'm going to write the rate of C times the time of C, substituting, plus the rate of M times the time of M, equals 66. So from here, I'm going to go back to my problem, and I'm going to look for information that I can find to fill in these rates and times. So, back at the problem, they tell us that at 1 p.m., Chester left, and it says that they finally met at 9 p.m. So if Chester left at 1 p.m. and they met at 9 p.m., he traveled for a grand total of 8 hours. So over here on time of Chester, I can put 8 instead. He traveled for 8 hours. Now let's see if we can figure out the time of Marshall. Let's see here, it says at 2 p.m. Marshall left, and then he met at 9 p.m. So from 2 to 9 is 7 hours. So we go back over here, go ahead and put in rate of M, and his time is going to be 7. Now I got to figure out something with their rates. So we go back to the problem. They tell us that Marshall Dillon's speed was twice that of Chester. So we have to turn that into an equation. So if the rate of M is twice of the rate of Chester, what do I have to do to the rate of Chester to make this true? Because right now this is not true. The rates are not equal. He went twice as fast. So if I multiply the rate of Chester by 2, now that is true. If I double his rate, it's equal to his. So I can substitute 2RC instead of writing RM. I'm going to go ahead and do that now. I'll also simplify these coefficients. So this equation can be rewritten as 8 times the rate of Chester plus 7 times 2RC instead of RM equals 66. That'll simplify to 14RC. 8RC plus 14RC, since they're like terms, gives me 22RC. And all of that is still equal to 66. From here, I just divide by 22. That goes in, or that reduces to 3 over 1. So the rate of Chester is equal to 3, or 3 miles per hour. Now, all I have to do is take that, plug it back into this equation. So RM equals 2 times 3. So the rate of M is equal to 6 miles per hour. And those are our answers. So, again, start with your distance diagram. Write the equation in terms of distance. Substitute in terms of rate and time. Plug in information that you have from the problem. And solve.